So this video is just going to be a quick introduction to inequalities. So on our course, we need to be able to solve inequalities like we do equations in algebra, and we also need to be able to graph inequalities. This video is just going to focus on revising the inequality symbols and then going through how to graph them. I will do solving them in a separate video. So I'll just start over here. So I read this as 5 is greater than 3, which hopefully you agree is true. Okay, so 5 is greater than 3. So the kind of open mouth here of the symbol is pointed at the bigger or greater number. So 5 is greater than 3. Here then, -2 is less than 7. So the kind of pointy end of the symbol is pointed at the lesser or smaller number. So -2 is less than 7. So 5 is greater than 3, -2 is less than 7. You can read them from right to left. So 3 is less than 5, 7 is greater than -2. All right, so it's whichever side of the symbol is pointed at something. All right, so the kind of open mouth is greater than, the closed side or the pointy side is the less than side. So 5 is greater than 3, -2 is less than 7, 3 is less than 5, 7 is greater than -2. We will generally read them from left to right, but it can be helpful to be able to read them from right to left as well sometimes. Just moving down here and just kind of introducing algebra a little bit. So this reads x is greater than 3. Okay, so if I got x is greater than 3 as my solution to something I was doing, well then x could be 4, 5, 6, 7, 8, 9, 10, etc. Okay, I just know that it's bigger than 3. All right, it's greater than 3, so that means it is not 3. It is obviously then not 2 or 1 or 0 or -1, etc. So x is greater than 3. This one here then, y is less than -12. So if I got that as a solution, it would mean my solution is what numbers are less than -12, well, -13, -14, -15, -16, etc. all the way down to -infinity. What's not a solution to that? Well, it doesn't say equal to -12, so -12 is not a solution to that. -12 is not less than -12, -11, -10, -9, all the way up. No positive numbers would be a solution for that either. Okay, so y is less than -12. Here then, slightly different symbol, so y is greater than or equal to 16. Okay, so the kind of double line on the bottom means or equal to. So if you got this as the solution, y is greater than or equal to 16, well, your solution then could be 16, 17, 18, 19, 20, all the way up to infinity. Okay, it can be 16 in this case because it's greater than or equal to 16. All right, it's not 15, 14, 13, 12, all the way down. All right, because it is greater than or equal to 16. Last one here then, just x is less than or equal to 2. So if you got that, what could x be? Well, x could be 2 because it's less than or equal to 2. It could be 1, x could be 0, x could be -1, could be -2, could be -3, all the way down then. All right, it's not going to be 3, 4, 5, 6, 7 because I've got x is less than or equal to 2. So anything bigger than 2 is not part of the solution set for that. As I said, the two things we need to be able to do is solve these and graph them. All right, I'll do the solving in a separate video. What I'm going to do over here is graph them. So when we're graphing these, we can be asked to graph them for different number sets. So this is revising what we would have done in the number or number systems chapter. All right, so for example, I'm asked to graph x is less than or equal to 3 on a number line, and I'm asked to do it 3 times. So I'm asked to do it for n, which is natural numbers, so the positive whole numbers. I'm asked to graph it for z, or integers, so that's positive and negative whole numbers. and I'm asked to graph it then for or, which is real numbers. Okay, so that is positive, negative, but not just whole numbers. Okay, includes fractions, decimals, all the numbers in between the whole numbers as well. All right, so you can be asked to graph either. So you're probably going to get one of these three sets in an exam question. Say it'll be N or Z or, and your answer will look a little bit different depending on which one you're asked to graph. Okay, so what I'm going to do over here is each one in turn. So just first, x is less than or equal to 3. And I'm asked to graph it for natural numbers. Okay, so here I've got a number line going from -3 to 7. So what numbers do I have on this number line that are less than or equal to 3 and are natural numbers? Well, 3 is a natural number. It's a positive whole number, and it is less than or equal to 3, so I'll put a mark on 3. 2 is less than or equal to 3, and it's a natural number. 1 is less than or equal to 3, and it's a natural number. 0 is not a natural number. Okay, so 0 only comes in with the integers. -1 is negative, so it's not a natural number. -2, -3, they're not. Okay, so on the other side then, 4 is obviously greater than 3, so it doesn't belong in the solution set. So that's the first part done. Okay, so the natural numbers less than or equal to 3 are 1, 2, and 3. Okay, not 0, not negative numbers, not 4 or anything bigger than 4. So that's that first part done. So I've just put kind of dots or kind of filled in circles on each of the numbers. The next one then, it says x is less than or equal to 3, and it wants me to fill in or graph this for integers then. Okay, so integers is positive and negative whole numbers. So positive and negative whole numbers less than or equal to 3. So 3, 2, 1. Integers is going to bring in 0, and integers is also going to bring in the negative whole numbers. All right, so integers less than or equal to 3 on that number line are 3, 2, 1, 0, -1, -2, -3. Now it's going to continue on down. It could be -4, -5, -6 if I was graphing that. So just to show that it continues on down to -infinity, I'm just going to go over the arrow. All right, so I'm just going to the arrow there, by filling that in or going over that myself, I'm showing that I know the solution continues on -4, -5, -6, -7, etc. Okay, but the important things with these ones are you're only putting dots on the whole numbers. Okay, so anything between 2 and 3 is not an integer, is not a natural number, because natural numbers and integers are only whole numbers. Third one here that I'm asked to graph then is the same inequality. X is less than or equal to 3, but this time I'm asked to graph it for real numbers. Okay, so real numbers now include all the numbers between the whole numbers, so all the fractions and all the decimals. Okay, so x is less than or equal to 3. So I suppose, what's the furthest to the right this is going to go on my number line? So x is less than or equal to 3. So the furthest it's going to go to the right is 3. Okay, anything further to the right there is bigger than 3, is greater than 3, and isn't included in my solution. All right. Now, unlike before, I'm not just going to now put a dot on 2 and 1 and 0 and -1. Okay, because this is real numbers that I'm graphing. Real numbers includes all the fractions and decimals. So it would include 2.5, it would include 2.75, it would include 2.18, it would include 2 and 7/8, it would include 2.99. So I need to show that I know everything in between 3 and 2 is graphed. Okay, that I'm including all the fractions and decimals in between those as well. So what I'm going to do is take my ruler, or set square in this case, and I'm just going to draw over the line between 3 and 2, And then I'm going to keep going, okay? Because I'm interested in all the real numbers less than or equal to 3. So that will be everything. Okay, so I'm actually drawing over the number line, okay? Because absolutely everything on that which is less than or equal to 3 is included in real numbers. All right, and then it's going to go past -3 and it's going to go all the way down to minus infinity. So again, I'm just going to draw over my arrow. All right, so you can draw over it like that, or you could maybe draw slightly above the line as well. If maybe you're using a black pen and the question that you're given is in black, you could draw over it to maybe make it a bit clearer. But just once the person can see that you're drawing kind of a full line for real numbers. All right. So look, the big difference is for natural numbers and integers, you're just putting dots on the numbers, on the whole numbers, because everything between the whole numbers is not included. For real numbers, you're actually filling in the line because it includes everything in between the whole numbers. All right. I would say in an exam question, you would be given the number line already drawn. If you weren't, and I think maybe if you're doing some in your book, you probably have to draw number lines yourself. For this one here, say x is less than or equal to 3. I've gone down as far as -3 and up as far as 7. What I would say is if you maybe go up a couple higher than 3, so maybe go up as far as 5 and go down maybe to -2, just to show like you know whether the negative numbers are included or not included. So if I was drawing this, I would go up as far as at least 5. I'd go a couple higher than 3 because that's the number in the question, and it would go a couple of numbers into the negative. So I'd go down at least as far as -2. So that maybe would be the smallest number line I would draw for that question. All right. Next one then. Graph on a number line, x is greater than -4. And again, I'm asked to draw it or graph it into 3 sets. All right, natural numbers, integers, and real numbers. Again, this is pre-drawn, and that's what you get in an exam. If I was doing this, if I was drawing this one out myself, it's x is greater than -4. So I was more interested in having stuff to the right of it. So what I might just do is go down as far as -6, just go a couple to the left of it, and then go up at least as far as 2 in the positive numbers, okay? Because then you can show, if you show that you know if positive numbers are included or not included, okay? Like if you only did -4 as far as -1 on your number line, you wouldn't really be giving yourself, you wouldn't be able to give yourself the opportunity to know how to do question 2, for example. Okay, so definitely go up and include a couple of positive numbers. So if you were drawing that, I would go down as far as -6 and at least up as far as 2 when I was drawing it. I've gone up as far as 3. Anyway, to graphing it, x is greater than -4 and x is a natural number. Okay, so greater than -4, so -4 is definitely not included. Okay, so this is just greater than, it's not greater than or equal to. All right, so it doesn't include -4. Does it include -3? That is greater than -4, yeah, but it's not a natural number. Okay, so natural numbers are only positive whole numbers. -3 is negative. -2 is negative, -1 is negative. 0 is not included in natural numbers. So the first natural number I have on my number line, which is greater than -4, is 1. And then 2 is a natural number and it's greater than -4. And then 3 is a natural number and it's greater than -4. And then 4, 5, 6 will be included. So I'm just going to draw over the arrow. All right. Question 2 then, or the second part of this. X is greater than -4. X is an integer this time. So doesn't include -4 because it's just greater than, it's not greater than or equal to. Okay, so first one I'm going to fill in is -3. It is greater than -4 and it is an integer. All right, so you're going to fill in -3 here. You're going to fill in -2. It's an integer bigger than -4. You're going to fill in -1. Integers include 0. Integers also include the positive numbers. So you're filling in 1, 2, and 3 as well. Okay, it's going to include 4, 5, 6, 7, so fill in the arrow as well. All right, last one here, and there's a slight difference on this one as well. X is greater than -4, and X is a real number. Okay, so again, it's not going to include -4 because it's greater than, it's not greater than or equal to. It is going to include -3. That's a real number, which is greater than -4. But is -3 the first real number on that number line, which is greater than -4? What about -3.5? That's a real number, and it's bigger than -4. What about -3.75? Yeah, that's a real number, and it's greater than -4. What about -3 9/10? It's a real number, it's greater than -4. What about -3.9999999? It is a real number, it is greater than -4, so I will want to put it on my number line. How do I do that? How do I show that I want my kind of line like I had in this question to get as close to -4 as possible without ever actually landing on -4, because I'm graphing greater than, I'm not graphing greater than or equal to. So the way we do that is we put a hollow circle on -4. So just this, and make sure it's quite clear that that's not filled in. Okay, so normally we're putting in a dot and we're kind of filling it in, or a circle and filling it in. That's to show the 3 is included. If I put a hollow circle on -4 here, I am showing -4 is not included in the solution. All right, and then it's greater than that, so it's everything to the right of that that should be included. So this is where I fill over the line. And again, that solution will continue to plus infinity. So I'm going to put that arrow in. All right, so X is greater than -4. X is a real number. It's everything to the right of -4, and it is everything. It includes all the fractions and decimals. So I want a line there. I want everything filled in between the whole numbers on the number line, but it does not include -4. So I put that circle in just to show that. All right, so that means it's everything down as far as -3.99999999999, but that line's never actually going to hit -4. All right, so just again there, why do I put the positive numbers in on this one? Because if you were, say, graphing that first answer there, natural numbers, and you'd say stopped at -1, well, you wouldn't have actually been able to graph that answer. So that's why I would say always put a couple of positive numbers in, or in this case here, a couple of negative numbers in. All right, you may or may not need them for your answer, but you're going to give yourself the opportunity to graph whatever they ask you to graph. All right, so go a couple to the right or left of the number in the question, and also go into the positive or negative as well, just if you're graphing them yourself. All right, but that's graphing inequalities. As I said, I will do solving in a separate video. And the important thing to get from this is just how to read those symbols and the difference between graphing n natural numbers, z integers, and or real numbers. Okay, because I would imagine in an exam you would just get one of those, and you need to know which one I'm being asked for and then how to graph it.